Welcome again, math lovers, on another problem from our channel. This time we have selected a number theory problem from Moscow City Math Olympiad from the year 1994. Generally, the math problems given in Russian Olympiads are very tough, but we have selected today a problem from the 9th grade, which is for students up to 15 years old. Of course, if you can pause this video and try to find a solution to this problem, so at the end we can compare our solutions. The statement of the problem is as follows. Prove that for all n from the set of natural numbers n, the number 2 times n cubed plus 9 times n squared plus 7n divided by 6 is also and always a natural number. So, in order to solve this problem, we should prove that the expression 2 times n cubed plus 9 times n squared plus 7n is always divisible by 6. So, without losing any further time, let's go directly to the solution of this problem. Of course, I have hidden the solution, so in order for us to go step by step through it together, and as we said a little bit earlier, in other words, we should prove that for every number, the given expression is divisible by 6. We start initially by some simple factorizations. First of all, we see that the expression 2n cubed plus 9n squared plus 7n, we factorize n, and we have on the brackets we have 2 n squared plus 9n plus 7. We see, let's say, with a little bit of experience and a little bit of problem solving, we see directly that minus 1 is a root of this second degree polynomial. So this means that this expression can be furtherly factorized as n times n plus 1 times 2n plus 7. We will call this form of the equation form number 1 and equation number 1. We should now prove that this equation in this form is always divisible by 6. So how will we do that? In this new form of the equation, we have two consecutive natural numbers, which are n and n plus 1. So this means that one of them surely divides 2, so is divisible by 2. And we must now prove that the expression of the equation number 1 over here is also divisible by 3 for every n from the set of natural numbers. To do so, we can let's say we can use the fact that every natural number can be expressed in the following form. N is equal to 3k plus r, where k is a natural number and r is the remainder of the division between n and 3, and it can be equal to 0, 1 or 2. So in other words, this expression represents with k the whole part of the division between the numbers n and 3, and with r the remainder between the division of the number n and 3. So given that every natural number can be of this form, we now prove that for every form of the number n, this expression is divisible by 3. So we have, in the case where r is equal to 0 and n is equal to 3k, in the expression n times n plus 1 times 2n plus 7, the factor n is divisible by 3. So we are done, because one of these numbers is divisible by 2. When n is of the form 3k, also the factor n is divisible by 3. So in this case, this expression is divisible by 6 and the problem is proven. In the case where r is equal to 1 and n is of the form 3k plus 1, then in the given expression, the factor 2n plus 7 is equal to, we substitute n equal to 3k plus 1, is equal to 2 times 3k plus 1 plus 7, is equal to 6k plus 9, is equal to 3, which multiplies 2k plus 3. So, when n is equal to the form 3k plus 1, in this expression, the factor 2n plus 7 is divisible by 3, and we have also in this case proven the problem. In the next and last case, where r is equal to 2 and n is of the form 3k plus 2, then in the given expression n times n plus 1 times 2n plus 7, the factor n plus 1 is equal to, we substitute n equal to 3k plus 2, 3k plus 2 plus 1 is equal to 3k plus 3 is equal to 3 times k plus 1. So in this case, where n is equal to 3k plus 2, in this expression the factor n plus 1 is divisible by 3, and we are also done. So in every case the expression n times n plus 1 times 2n plus 7 is divisible by 2 and by 3 contemporarily, which means that it is also divisible by 6 for every n from the set of natural number, which was to be proven. Please write down in the comments if you have any other idea for the solution of this problem, and thank you for watching. Bye.